Well, welcome to Knock Knock, Who's There? Identifying Assets in the Cloud. My name is Ben Sadehipour, but most people know me online as Nahamsek. I am currently the head of hacker education at HackerOne. I also, on my free time, create content and stream hacking on YouTube and Twitch. You can follow me on all social media platforms under @Nahamsek. I also have Tanner Barnes here with me. I'll let him introduce himself real quick.
Hi, thanks, Ben. Yes, my name is Tanner Barnes. I am a developer, a pen tester, and an occasional bug hunter. My day job, I'm a cyber consultant for Aon Cyber Solutions. And the tools that I build for the cybersecurity community, you can find at my GitHub there. And I do some occasional live development at that Twitch handle.
So what's our agenda like today? We're going to talk about why the cloud is so important. We're going to show you all our solution and how we accomplish all of our scans and the things that we did with it. Then we're going to talk about mass exploitation and how we found vulnerabilities after scanning hundreds of millions of IP addresses. And of course, we're going to have some really, really cool examples to share with everybody.
Awesome. Right. So the first question really, when starting something like this, is why scan the cloud? Well, for one, it was still cheaper for ourselves to do than buying something like a Census or a Shodan license. And then secondly, it's a really target-rich environment. You know, nowadays, everyone's in the cloud. Any type of your large, Fortune 100, Fortune 500 companies are going to have assets out in the cloud. If you're looking at just cloud-specific compute ranges, you're looking at 88 million to 100 million IP addresses out there available for clients of theirs to spin up instances on. And the nice thing is we found with looking at this data that a lot of this space is used for these companies to spin up development instances or things that they're working on live. So if you're able to get really high fidelity and really constant data on what's out there on those IP ranges, you can actually end up finding a lot of really exciting targets as they're being deployed. So to give an example of that, we took a look at some of the DNS names we were finding in these certificates to get a sense of what is kind of out there. So you're looking at some corps, some internal, which we found fascinating. A lot of DNS names with the name internal in them, even though they're out there on the public internet, was very fascinating. Dev, like we were saying earlier, a lot of companies like to put their development instances for new products they're building out there on the cloud. Lots and lots of APIs, especially as people look at scaling up their APIs for access to worldwide audiences. And then as an example of two different companies out there, Oath for Verizon with about 5,000 and Yahoo with quite a staggering amount of 108,000. So this is the fun part. We're going to talk a little bit about how we actually accomplished covering such a large space like that so quickly. So as far as the code goes, it's built in Go. I'm a huge fan of that language. I learned it last year, and its Go routines is really built for this type of distributed parallel work. As far as how it works, it's very simple. We're looking at IP addresses and pulling out the CNAME and DNS name records from those certificates. There's not really a lot of magic in the code. It's a very simple piece of software, but the real magic comes in being able to scale it up to cover such a large space. Right. So this is a really fun slide. When I showed this to Ben, he was really excited, as well as some other people. We're looking at about 1.4 billion unique targets in the space of about 15 minutes, which comes out to a rate of 1.6 million a second. It ends up being about 28 million identified targets across 11 different ports that we identified as kind of high trafficked ports. And the other magic part is that all this is done for about $25 in AWS charges. So with every good side, there's also a bad. We learned a lot of lessons on our way to that kind of mythical $25 in AWS charges. One, don't try this with Lambda. An initial try with being able to spread it out over Lambda workers is impossible. They won't let you spin up that many. And once you start them, there is no stopping them. So we had a handful of AWS bills that were quite exciting to receive. And on the code side, every little bit of memory and CPU cycle matters, especially when you're trying to cover this work as quickly as possible. With AWS billing you per second, the quicker you can do it, obviously, the lower your bill becomes. So once the code was written, it was a lot of work to kind of profile it with memory and CPU profilers to get every little bit of performance out of it. As kind of a final note, it was important after we had these resources that we found from the scanner to make sure before delving into any of them that they were specifically bounty targets. We got some very exciting, angry notes on LinkedIn and our email accounts from CISOs who were not at all pleased we were taking a look at their resources. Right. So once you have the data, that's all well and good, but it's important to enrich it in ways that makes it easier to process. So some of the ways we identified to enrich this data are here kind of below. So one thing we did initially was to take a list of curated bounty targets that we were familiar with and that were out there and known about, and pulled out from our large list of mappings all those targets which were bounty targets. So that will give you a quick one-off way at the start to really filter your list down to targets that are for sure in a bounty scope. Once we had that data, as we started doing the scans more often, we started doing a diffing of scan to previous scan. This allowed us to really quickly, from those bounty targets, realize what was most recently spun up since our previous scan. And that was really the more fresher of the targets, which is more of a ripe area for finding bounties. Another thing that had a lot of really great benefits for us was doing some vhost discrepancies. So taking a host and accessing it by its IP address, accessing it by its DNS name, and then accessing with a host header of localhost, and checking the response links and response codes to seeing hosts that maybe weren't answering on their DNS name, but were accessible with IP address or a host name of localhost. Kind of two final things. We're pulling the raw titles of the pages that came back, the response links and status codes, to get a sense of which targets might be more interesting to go after, and then some general fingerprinting of services that were live in products. So if for some reason a CVE was to appear in a product, which we'll get to later, a specific example, we were able to quickly zoom in on those targets that match that service and start looking at those immediately. Right. So 1.4 billion targets creates a lot of noise. We found this great list on GitHub. It's a little hard to pronounce that name, so I'm not going to butcher it for them. I'd hate to say it wrong. So that list was a great jumping off point for finding bounty targets that we could start filtering. So that filtering is done for us at scan time and puts it into two separate buckets of targets that we can start looking at immediately and processing for further tooling. Right. So back to the scan diffing. So multiple scans are obviously going to have overlap, right? If somebody like Tesla has their homepage out on the cloud, we can pretty reasonably assume that that is always going to be in a scan every time until their company goes under. Hopefully not. But things like that can really fill up the scans with noise. So it's helpful to do a diff scan to scan to kind of weed out the things that are always there and look at what might be new. Another thing that diffing has helped us with is it allows us to learn how targets over time name their hosts. So some of these targets we were looking at, some of these bug bounty scopes, we were starting to get a really good understanding week over week how these companies were naming their cloud resources. And in some cases, we were able to already know what a host's DNS name was going to be before it was even live, which was really exciting to see. Yes. So After that, another fun thing that we decided to do that would really give us a deep insight into some of these hosts was virtual host discrepancies. So you take an IP address and you send it a request of 3 different types. So you send it as a request to the IP address with a host header of the IP address. You send it with the IP address and a host name of the DNS name you're interested in. And then finally, the IP address with a host name of localhost. And then you look at the response length and the status codes of all 3 of those to look for discrepancies. As an example, on a bounty target, this was an AEM instance that was vulnerable, that was only accessible by IP address. So knowing the host name was helpful, but you wouldn't be able to access it that way. But if you hit it directly by IP address, you were able to get access to the instance.
Cool, awesome.
So I'll kick it off to Ben to do some talking about some of the exploitation we were able to do with these hosts.
So when it comes down to mass exploitation, you have 2 options. You can either go after a single target, or you can just go after every single one of your targets that you're hacking on and look for the same pattern. But if you decide to do single target, this is how we approached it. So first of all, we want to understand how this target works. Are there any specific deployment process they follow? What are the APIs being deployed? Where are the documentation for those APIs being stored? Is it going to be in a particular folder? Is it always Swagger? Is it always an application.waddle? Who knows? We want to figure those out. And then we want to also understand, where are the internal and corporate sites? So is it corporate.site.com, or do they have an actual corporate domain where they host all these things? Well, as an example, with Verizon Media, we came across a bunch of application waddles, a bunch of Swagger UIs, and we noticed that a lot of the internal targets were having the port 4443 open, and it was very, very interesting. So we decided to keep analyzing this pattern on every target we went to. But on the other hand, when you're doing multiple targets where you're spraying for vulns and praying that it comes back as a valid vulnerability, it's a different approach. The first thing is you look for CVEs, things that you know are already vulnerable. You look for other development processes like a backend that companies may use, like Spring Boot or Jalokia, where you know there's going to be potential vulnerabilities there. Of course, the API documentation works on both approaches of single target and multiple target. And then last but not least, this is my favorite thing to look for, is looking for sensitive or internal tools that are not supposed to be exposed. These are things like Jenkins, GitLab, GitHub, Jira. And of course, all of these are approached differently, but it's very, very good to have. Now let's talk about when mass exploitation and avoiding false positive, because if you want to avoid false positive, identification becomes a very, very important part of this. So how does it look? Well, you have to understand what you want to go after. You can't just say, I want to look for all these things. You have to understand how GraphQL works, what APIs look like, what Grafana looks like, what makes these things unique. So for example, in most cases, you want to look for 3 things. The response header, because in the header, sometimes I have a signature that defines what this program is or what this application is. The response body, because it could have a signature in the body that says powered by so-and-so company. And of course, a specific endpoint. That endpoint could be a logo, it could be an API endpoint, it could be an error page, whatever you're looking for. You have to really understand what that means. So for example, we were looking for Swagger. I've brought this up a bunch of times. If you're looking for Swagger, 9 out of 10 times, you can come across this endpoint called Swagger Resources, where it tells you where the location of the documentation is. And of course, there's a keyword Swagger version that you can use as a part of the fingerprint. And we'll talk about that in a little bit again, and we'll put it together to understand how to actually look for these in mass. So of course, if you don't find the Swagger resources as this one, you can always just spray for Swagger API docs and other paths that you know of that API documentation could be stored within Swagger, and look for the keyword base path. The base path is something that every single documentation will have, and they have to tell you where the API exists, how to access it, where to access it, and so on. And before I move on, I want to make a note that just finding this API documentation is not a vulnerability by itself. It just helps you not have to play hide and seek with the API. It tells you where the endpoints are, how they work, what to expect, and so on. So please don't report, Swagger documentation on its own. Spend some time to understand how the API works and look for vulnerabilities within those APIs. The next one is GraphQL. What makes GraphQL important or unique is if you hit a /GraphQL endpoint, in most cases you're going to get a 400 error, and it's going to return an error that says, hey, the get query is missing. So knowing that query missing is going to be in our response, when we hit GraphQL and we're expecting a 400 bad request, we can use this as a fingerprint to always look for GraphQL instances across all of our bug bounty programs. And another example is one of my favorites. Big shout outs to Ridonator for doing this, Justin Gardner. He found a CV in Grafana. We're looking at this data and we'll talk about it a little bit. But Grafana, it's really easy. If you go to the web root, it 302s to login, and within that response, you will see Grafana in the title, and you can also see the public image Grafana mask icon that makes it very, very obvious this is Grafana. So if you see these three things, there is a high chance that this cannot be a false positive, and Grafana instance actually exists on that IP address. All right, well, we knew all of this, but now that we know how these things look and how to look for them, what do we do? Well, while we're developing this scanner, we didn't have a lot of tools of our own. We're still figuring out how to do it. So we decided to use tools that are already out there. I personally love using Meg. Huge shout out to Tom Nom Nom. If you're not familiar with Tom, I definitely recommend following him on Twitter and checking out all his awesome tools that he has put out for bug bounty hunters on his GitHub. But Meg allows you to spray a number of endpoints against a ton of hosts. And it goes a step further and it saves the response code in a folder called out, and it indexes them. So as you can see, each line is a host that I've hit. It on the left hand side, it's where it stored the response code and response headers and everything that came back. On the right hand side, it gives you the response code and it gives you the URL of whatever we hit. So if you go, for example, I'm looking at Netflix. If I go to ls and do ls out on Netflix, you can see every IP address that I've hit. It has it organized for me, and within that folder, the response body is fully saved. This is all very, very useful, and we'll talk about it in a little bit as well. So now that we know all this information, we want to put a one-liner. You can use whatever language you like. I like doing things with grep, and I promise you this is probably not the best way to do it, but it worked. I made this thing up. I will explain what it does in a sec, but I saved this as a bash alias called search. And every time I would get done scanning with Meg, I would type in search and look for whatever I was looking for. So the first thing we're doing in that command that I just showed earlier is we're grepping for the response code. So if I'm looking for Swagger, if the Swagger documentation is there, I'm looking for the status code of 200. Here I'm looking for metrics. That doesn't matter what we're looking for, but we want to make sure the status code, the response code matches first. Next, we're telling it, hey, I want you to cut the output and tell me where the path for the response body is. So if you match the 200, tell me where the file is, where the response body is saved for that IP or domain address. And then we do a sort U. It's a bad habit of mine. It's just to make sure there are no duplicates. And right after that, we're going to pass it to xargs, and we're going to say, hey, I want you to loop through all of these, and I want you to grep for the fingerprint that we came up with. So if I'm looking for Swagger, I'm looking for Swagger version. I want you to open every one of those files in those folders, look for that fingerprint, and then after that, I want you to cut it up and give me the IP address or the domain where this thing was identified. So we've saved it, we ran it, and now we're going to look at some examples. So like I said, I've called this thing search. It's just an easy thing. You can call it whatever you want. I'm looking for 200, the status code being 200. And again, as we mentioned earlier, Swagger version is our benchmark or our fingerprint, whatever you want to call it. And then we ask, we cut up a little bit more. And on the left side right here, all these, the white box right here is pretty much every IP address that came back within Netflix's infrastructure that had Swagger version and that endpoint that we hit, Swagger resources. Same thing for GraphQL. We did the same exact thing. We said search for 400, and if there is a 400 status code, read the body from that folder, tell us where the keyword missing comes up, and then spit out all the IP addresses for us. So all these IP addresses had a working GraphQL instance that we could have played with and see if we can find vulnerabilities in. But all of that is fine, but I don't think it scales, especially when you're going after millions of IP addresses and you're mass scanning almost the entire internet. So I'll let Tanner really quickly explain how we approach this on our own and how this tool works.
Right. So one of the things we wanted to do with all these hosts was get a good sense of what was running on them. So the easiest way to do that is find something that is identifiable in the HTTPS response of these hosts and key off on that and build yourself a list of those identifiers. So that's exactly what we did. It's a very simple tool. It's very similar to a lot of the other fingerprinting tools. We built one kind of ourselves just to have an easy way to tie in to our scans that we run ourselves. And this is triggered automatically after our new scans come in. So you can see an example over there, to the right, where you just have the name of the service you're interested in and the fingerprint or fingerprints that it's going to be looking for in either the response body, the response headers, or really anywhere in any of that response data that comes back.
And the good thing about this tool is that you can also add, to this JSON body and add whatever fingerprints you want and customize it to your needs. We've released this and we'll talk about it later on during this talk. Now let's talk about some bug bounty examples. I think this is where the fun happens a little bit for us. So we wanted to talk about asset monitoring. As Tanner mentioned earlier, we caught on to how this company was deploying things, what they were deploying and how they were doing it. And it ended up giving us some really cool vulns. Unfortunately, because it's a private program, we couldn't do any screenshots, but what I can do is give you a high level overview of what happened. So about a year ago, I discovered an XSS in this application. What it was, every time that you would go to this website, you go to /demo or demo app, it would take you to this folder in this file where that parameter had an XSS in it. We reported it, never thought of this ever again, but me being me, I saved that path of demo app /demo_app.html. I put it in my keywords or my word list. If it comes up, it comes up. Well, a year later almost, I come across the same company, and I realized that this thing came up in a development environment. Well, that's interesting. I have this in my word list for a reason. I've came across it before, and I've seen this already. Well, let's create a fingerprint. The fingerprint that we created was a JavaScript file that would be called within the body of this file, in the HTML file, that they relied on their CDN. So all we had to do was use Meg or use our tool, either one, and look for this path right here and make sure the fingerprint of our JavaScript file that we have found was in there. And within our scan, we found 6 different instances of this where it was vulnerable to an XSS. And that's an easy win. So every time a new asset comes up for this company, we hit this endpoint. Is it there? Awesome. Let's exploit for XSS and let's report it. The next one is hunting for CVEs. This is Elite CVE, as you can see, CVE 2020 13379. I'm not going to talk about the technical aspects of this talk. If you're interested in this, please go look up Rhino Raiders, SSRF, and Grafana on YouTube. I think he did a talk at HacktivityCon with HackerOne. I highly recommend it. It's a very, very good talk on SSRF, and it helped us identify some vulnerabilities using this bug. So we talked about how to look for Grafana. Obviously, Grafana goes to login when you hit the web root. The keyword Grafana is in there. But then we later on learned that Grafana is also hosted on the port 3000. Great. Let's scan for port 3000 and look for everything that has Grafana in it in our bug bounty table. So we pulled everything from port 3000 from bug bounty table, as I mentioned. We also looked for everything that has the keyword Grafana in it from the bounty table. We hit /login with Meg. We fingerprinted for it all, and we used our search thing, and we found all the possible instances of Grafana that were existing in our database. But we could have skipped the login part, and instead of looking for login, since we know the POC for this thing, we could have literally just used the SSRF, have the SSRF hit the 169.254.169.254 IP address, where it's the AWS metadata instance, and look for the keyword metadata. And if that comes up, then that means it's vulnerable because it's giving us the cloud instance or cloud metadata instance because it's vulnerable, and we can identify it using Meg. So as an example, here is what we have found with some of the bug bounty programs that we have hit. One of these companies, we identified several number of vulnerable instances. They were kind of impressed with how we found it. And this is kind of how we did it. It was with the scan that we were doing continuously with Tanner. And there was not just that company, there were other companies that were also vulnerable to this that we came across. So it was really, really fun to be able to find these things because of the research that Ryan has done and the research that we were doing in parallel between me and Tanner, and we got to get some really cool bounties out of it. Takeaways from this is, just because a company has multiple instances of the same app, it doesn't mean that you're going to get multiple bounties, but multiple instances sometimes means a higher reward or maybe a bonus on top. Also, if you're going to hunt for CVEs and O days, give them some time to patch. Don't do it the same day it gets dropped. You're going to piss people off. You may get upset because they're not going to pay you, but just give them enough time. Give them 30 days, 60 days, whatever that is. It's appropriate time, whatever you think it's appropriate. And then if you report it too early and you don't get any money, don't get upset. It's just a part of the game. That's what happens when you go and hunt for O days. The next one is the classic admin. We sprayed admin across our entire bounty table, but we didn't find anything interesting except this one instance where we would hit admin and we were looking for login, but we realized the login was pretty much sending us to another path called MGMT, which we assumed it was management, some path, and then login.jsp. And of course, MGMT had a login page that was admin. As you can see on the right, this is what it looked like. And of course, if you use the credentials admin, it led us into this website's backend and it gave us some user data, but that wasn't enough. That's not fun because we have access to this one backend. So what? The thing that I'm interested in is this company reusing this management backend over and over on other websites? And can I log into those using the same admin credentials? So let's break this down apart. The WXYZ that we have is the application name. That always stays the same. So if this was some weird name that we knew about, that's always going to be there. The permutation was a little bit weird because it wasn't the traditional dev, internal, corporate. These permutations, I think, were different platforms where this thing was being used. And then obviously the I wish I could disclose this target.com is the domain that we're going after. And the core app is where you would get logged in. So once you log into the website, it would send you to that core application. And that was very interesting because it was very, very unique. So it made it really easy for us to fingerprint. So I go back to our database. We look for everything that had the app name. Let me go back to it. So anything that had the WXYZ, we want that. And we want to make sure it's within that domain that we're hacking on I wish I could disclose this target.com. We fed that to Meg in our search tool, and then we see how many more came up. And I think we roughly found about 15. I know it says exact, but I think there were some other issues with some of the IP addresses. But out of those 15, 12 of them were vulnerable, and we can log into 12 of those with admin. Each of those had access to different platforms this thing was being used on, and each of those have different users with PII, and I think it was roughly about 1 million users data that was accessible. And also, I think the website had RCE by design. I think it had some really weird file uploads, some stuff to control servers. So by default, we could have probably RCE'd this thing. But when you're inside of an internal website, from a corporate standpoint, you don't want to push those limits without their permissions. So we reported them, pointed out that, hey, there could be RCE in here, and we let that team take care of the rest of it. And this one is, I think, one of our last examples, and one of my favorites is where we got to fish for employee sessions by looking into heap dumps of this particular company. And let me explain. So before we get into that, let's talk about what a heap dump example looks like, how we identify it, and so on. So if you go on Spring Boot's documentation, there are a few things that we understand. There are a few really interesting endpoints. One is the HTTP trace, which provides information about the request response exchange. So if you send a request to that website, it pretty much stores it on that endpoint, both your request and the response, and it also, captures the headers, including the cookies and so on. The heap dump, obviously, it's a heap dump from that application's JVM. And in the response headers, there is a content type that says application, VND, Spring Boot, actuator, whatever version, plus JSON. So 3 things that we cared about. Does the content type return this? Is there a 200 for HTTP trace or heap dump? If there is, we need to exploit this. And we did. So a big shout out to ZLZ and Zayat. These guys really wanted to own this megacorp. This is one of the biggest companies I've ever had the pleasure to hack. And unfortunately, I can't disclose who they are, but let's just call them megacorp for this instance. So we went back, we dumped every asset we could find, and we sprayed HTTP trace against all domains. We discovered and came across a bunch of different HTTP traces, and the pattern looked like XYZ internal prod side actuator HTTP trace. That was the first one we got to identify. And this is what the response looked like. So if you can see that the URL there, it says what kind of request it was. It was a GET request. There was a cookie for the header for the cookie, and some other information. And you can see at the bottom right there, it says internal prod megacorp. And it was weird. Why is it both internal and prod? I want to know more. So what can we do? We'll go look for XYZ, whatever the application name is, and we want to identify different permutations. So we identified 4 other instances, the last one being the one that we already knew about, internal prod. Then we realized there's also internal, and there's also prod, and there's also just the app.site.com without any permutations. So we started brute forcing for actuator, HTTP trace, and so on, and we came across these last 4, which gave us some credentials and cookies that we could potentially use. And as I mentioned, as you can see on the screen, these were a little bit useless because we couldn't use the set of cookies that was given to us initially, but there was something there. We can't just let this go by itself. There's got to be more stuff coming in. So we decided to look for other endpoints. Let's forget about actuator. Let's forget about heap dump. Are there other things being hosted on this site? And we found that. So the first one was we found a folder called core app. We found a folder called application. We found a folder called viewer. And then we found a folder called XYZ services, where XYZ is the name of the subdomain that we had. And it just had its own folder within it. And within all of those folders, we came across more actuators, more heap dumps, and more HTTP traces that had more data in it. So once we were able to collect all of that data, we queried for every single heap dump. We collected every single HTTP trace. We collected everything that had the keyword cookie in it. And we started to load these cookies into our burp and started to match and replace. And we're actually able to eventually log into an externally exposed internal asset owned by this megacorp. So as you can see here, we were logged into some internal site where it had almost all the employees' data. We were able to edit, deactivate, delete. This one was some sales website, I believe. We didn't want to dig into it too much. We left it alone as it was. This is another one. I can't explain really what this one was, unfortunately. But these were all internal tools that we had got access to. But there's a lot of lesson learned here. If you come across a heap dump, for example, or an HTTP trace, stop brute forcing so you can monitor for cookies. Take a break, come back the next morning, hoping that it's still there, and make sure you monitor for it. As you can see here, ZLZ is like, hey, is anyone directory brute forcing? Yep, it's Ben. I can see all his requests going in live. Can you stop so we can wait for these companies' employees to log in and capture a set of credentials? And then we also realized this isn't the only place that uses this. I've seen this a number of times on other places. So let's go back and scan a few other organizations and see if we can find more results. And of course, we were able to find a few other ones, as you can see on the screen, that gave us some really good vulnerabilities. I'm going to switch over to Tanner and let him talk about some of the cool stuff that came out of this research, some of the tools and releases that we have done.
Awesome. Yeah, thanks. So we are going to release 2 tools that we use internally with our scans that we talked about previously, right? So we have Go Fingerprint, which allows you to supply a JSON file with your fingerprints and then a list of URLs to test them against. And you can see in that top right what the output looks like. You'll get the URL that matched a fingerprint, a colon, and then the fingerprint that it matched. The second one is vhost scan. So it takes a comma delineated file, of the host name, the IP address, and the port. And then for those lines, it will test for those 3 different access variations with the host name, with the IP address, and a localhost host header. And then it will turn you a JSON file containing all of those targets with the host, the status code and the response link for those 3 checks that you can use to the differences of just try to find some vulnerable targets. As well as those 2 tools, we have also, this is going on month 2 of recon.dev, our site for being able to access the scan data. So we're up to 300 million plus IP addresses that we're targeting, again, across those 12 ports. We update the data weekly. We also have plans as we kind of move along to possibly be updating this data more frequently, but for now, these targets are updated weekly. It allows you to query 1 domain at a time, and you'll return the data in a JSON array with the IP address, the port that it was found on, any domain names from the certificates that were scanned, along with some other data that we might be making live here shortly. This is accessible through the site. Sorry about that. It is accessible by the site or through a CLI API off of just through curling or through Python or however you want to actually access the data. Using it through the site is not required.
Awesome. Thank you, Tanner. Let's wrap this up really quickly. There are some things I want to address before we end this talk. First of all, if you're getting into bug bounties, please take the time to understand your target. Understand how to deploy things, where do they do them, how they do it. Look for patterns of mistakes, and abuse those as much as you can. Familiarize yourself with all these things that you see frequently. It could be a particular app, it could be a particular backend, whatever that is. Install it locally, mess with it, understand it. Get really good at fingerprinting. If you want to get into the recon thing, understand how to fingerprint things so you can identify them on the fly as you're scanning things. And of course, last but not least, create a good database of assets you can hack on. It doesn't have to be, you don't have to overdo it like this, like we have, but have a text file. Have somewhere where you store all your data, your historic data, and always go back to it and look for differences between your last scan and your current scan. That could be very, very helpful if you want to become successful in bug hunting. A lot of the things that I've mentioned during the examples with Tanner aren't things that are super new. Again, when we were doing this research, we did this research in 3 months. We were going to do it for a year. We cut it down to 3 months because we wanted to get ahead of it a little bit. So we wanted to look for low-hanging fruits, and we did. But think about it from an adversary's point of view. For example, when we had access to those internal assets from the megacorp, we could have just started our own campaign within being internal on that company's internal network, on their internal assets and applications, and see how far that could go. The second thing is, don't just collect assets and data and spray them with generic word list. There's a lot of times where you can go into an application, you need to be logged in before you can do anything to it. So dig deep. Go into their login, sign up, log in, and do your recon within your session, and not just automated where you just throw things at it and hope something comes back. And a lot of times, again, you want to understand your application and you want to understand that site, and that's going to take you the longest way possible. And there's a lot of hate and there's a lot of criticism for bug bounties, but I'm going to tell you this from someone who's been doing bug bounties for years. You're only going to get back what you put in. So if you want to become good at bug hunting, find bugs with actual impact, forget about best practices, forget about missing headers, forget about all that stuff. Find ways you can either own a customer own a user on that site or own that company's infrastructure. And again, I've said this a million times, spend time learning your target's behaviors and make sure you understand how they operate. And this is just a meme I wanted to throw out there. There was a lot of really good vulnerabilities. I've talked about patterns a lot. You see the semicolon pattern. There's a lot of good tips about it. There was a lot of good research that came out because of it. Path normalization is really, really good. I highly recommend watching Orange Size talk on this from a few years ago at DEF CON. But I wanted to throw that out there because we did some stuff with it in mass with all the data we had. And there is a lot to be done with this kind of vulnerabilities. And last but not least, I want to say a huge thank you to Zayed, ZLZ, Donut, Pointer, Tom Nom Nom, Irby Sam, Rhinorator, and of course Tanner for being a great partner in crime. And thank you all for watching this talk, and we appreciate you.
Thanks, guys.